Okay, so I now propose to start this seminar. So welcome to all of you. Thank you for being present. So today with LIBM, we organize a virtual seminar with Giacomo Valli presenting some interesting stuff related to his research activities. So Giacomo obtained a master's degree in sports science at the University of Urbino. And he is currently a PhD student at the University of Padova with research activities targeting, let's say, neuromuscular plasticity. And Giacomo has a strong passion for coding, and this is why he developed an open source project, an open source software to do analysis of HD-EMG signals. And today, Giacomo will further present his interest for HD-EMG and the open source software that he developed. So thank you very much, Giacomo, for presenting today. We will have almost 1 hour of presentation from Giacomo with time for questions at the end. But if you have any question during the presentation, feel free to ask during the presentation so that it can be a bit interactive if you need to. So Giacomo, thank you, and it's your turn.
Okay, fantastic, Thomas. Thank you very much for the introduction. So today we are going to talk about openhdemg. So this is a project that maybe most of you have heard from Twitter, or you have seen us at seminars and conferences. But this is the first time that we really present the entire software. So also, Thomas, thank you very much, because this is a fantastic opportunity for us. So I will first of all introduce myself, because as some of you might not know me, I have a master's degree in sports science, although, to be honest, I never worked that much in sports science, because during my master's degree I've been working mainly on the molecular biology part of the muscle, yes, but it's not related to sport just because there is the muscle. And after my master's degree, I moved to Padova, where I've been doing my PhD. I'm working in Padova with Professor Giuseppe De Vito, and my PhD is on neuromuscular physiology. So I'm now at the end of my PhD. It will end just at the end of this month. So in few days I will move to Brescia to work with Professor Francesco Negro, where I will continue working on neuromuscular physiology, but I will also work quite a lot on the HD-EMG technique itself. So today's agenda is quite extensive, I think. So the presentation is gonna be long. I expect it to be about 1 hour. So if you have any doubt or question and you want to understand something in the meantime, feel free to raise your hand or to unmute yourself and ask questions at any point. So today we will mainly discuss about the openhdemg project, but we will also do an introduction on high-density electromyography so that anybody will be able to follow the remaining of the presentation. So after we talk about high-density electromyography, we will see what are the challenges that we are facing for the adoption of the technique itself. And then we will go straight away to the openhdemg project, and we will look at what it is, why we need it, what can you do with it, how can you use it. And after that, we will also look at the future development of the project, because it is not something that we create and it remains as it is. And we will also look at how any of you, if interested, can contribute to this project. So just a quick note. Today we will not talk much about high-density electromyography itself. So if any of you is interested in this, in 2 days we will be in Basel, this time in person, and we will be talking about high-density electromyography, also on the data collection side, so it will be more technical, and then we will complete the discussion with the openhdemg project again. So if you are around Basel, you can come to visit us in person, or you can follow the meeting via Zoom if you wish. And this presentation is organized by Paul, a colleague that is also one of the developers of the openhdemg project. So, okay, let's start from the first question. So what is high-density electromyography? So we can understand this by dividing what is electromyography, first of all. Electromyography is a medical and physiological technique that we use to record and analyze the electrical activity of the muscle tissue. This was originally done with intramuscular EMG, which means that you can use a needle which has an electrode at its point, and you can record the electrical activity of the muscle directly from inside the muscle. This has a very good advantage, which is that you bypass the volume conductor, which is everything between the muscle and the surface of the skin. So you have a very good signal, a very defined signal, and so you can really see the action potentials of the motor units. On the other side, we have surface electromyography, which in the past was almost always done with a pair of electrodes that were attached on the skin. So at this stage, surface electromyography had many limitations because we could only see one surface electromyographic signal. The signal was filtered by the volume conductor, so the action potentials were not really distinguishable, and therefore it was not possible to analyze motor units properties from this technique. With time, there has been an evolution of the grids that we use for the recording, and we now have a variety of them. Now we have a variety of grids of electrodes that change in shape, but most important, they change in the number of electrodes. So by definition, high-density electromyography is that technique that involves the concurrent recording of at least 4 electromyographic signals with closely spaced and small diameters electrodes. To be honest, this definition is specific for surface electromyography, but very recently also have been developed some technique for intramuscular high-density electromyography. But for today's presentation, we will mainly focus on surface EMG, although most of the analyses are similar, but there might be some differences. So we'll just focus on surface EMG. What happened here? Okay. So high-density electromyography means that we are recording the action potentials that are generated and that propagate at the muscle level from different points of view, which means from different electrodes on the skin. The signal that we record looks more or less like this, which, to be honest, looks like a messy signal where it's impossible to understand any specific behavior, and it's very difficult to discriminate the action potentials, and it's even more complex to associate this action potential to a specific motor unit. That's why the composition techniques have been developed, and these techniques have the great potential of identifying the time instance in which each different motor unit is active. So in this case, the motor unit is active here at this time, but is not active at this time where the second motor unit is firing. This is a very important information because just with this one, also combined with the surface EMG signal, we can perform most of the analysis. And for example, we can also estimate the shape of the action potentials and how these propagate through the muscle. In high-density electromyography, we can usually analyze 2 types of parameters that are often defined as more peripheral and more central. And in my opinion, this is a difficult part to understand. So to understand the peripheral properties is quite simple because, for example, we have motor units conduction velocity, which is the velocity at which the action potentials move through the fiber. So it's obvious that this behavior is determined by the muscle fiber itself or by the ion channel, but usually by metabolic and structural parameters. So for example, this year Andrea Casolo published this study demonstrated that motor units conduction velocity is highly correlated with the size of the fiber. So the larger the fiber, the higher the conduction velocity. And therefore, conduction velocity is a very important parameter also in physiological studies, and is clearly of the muscle. More difficult is to understand why we talk about more central properties. And for central properties, we mainly refer to the discharge rate behavior or to the recruitment and the recruitment of the motor units. So as we see here, the signal that the muscle receives is the series of action potentials that generate and transmit through the motor neuron. These action potentials are generated via a combination of the signal coming from the motor cortex and all the feedbacks that are integrated at the spinal level. So the discharge activity of the motor neuron is reflecting a central activity. But the motor neuron itself is responding in a very simple way to the inputs it receives. So the higher the input, the higher the discharge rate that it produces. Of course, this is a simplified model, but it's sufficient for what we want to look today. But the muscle is not responding the same way. In fact, if we increase the discharge rate to the muscle, the force that it produces at some point increases linearly, but then it starts reaching a plateau. So we have a sigmoidal relationship between the discharge rate and the strength produced by the muscle. So at first, for me, this was the greatest obstacle in understanding why we can talk about central properties, because the response of the muscle is not the same of the motor neuron. But the very interesting point is that, as also showed by Del Vecchio now 3 years ago, at the muscle level, so with high-density electromyography, we can detect discharge activities of the motor neuron, which are much higher than the discharge activity that is required to reach the tetanic contraction at the muscle level. So the muscle can reach the tetanic contraction at about 40, 50 impulses per second, but in this case, during explosive contractions, so very powerful and fast contractions, he has been able to record up to 120, 150 impulses per second. That means that the discharge behavior of the motor neuron is reflected with a one-to-one relationship in the muscle, so in what we can record with high-density electromyography. Okay, I think this was a necessary introduction. So now we all know what we are talking about, central and peripheral motor units properties. We know the most important and I would say basic properties of the motor unit behavior. And although this might look simple, this has been sufficient to do the majority of the studies that have been conducted with high-density electromyography. And these studies have been very important for the definition of motor units physiology, but also to investigate the neuromuscular adaptations to different conditions. But the interesting part is that even if many studies came out with high-density electromyography, there are not many research groups that are using this technique. And this is because there are a number of challenges that prevent the widespread adoption of the technique. So here there are just few examples, but the equipment is expensive and not everybody can have it available. But also the data collection itself is complex because you need to be very careful on how and where you apply your grids of electrodes. And once you collected your data, the signal processing itself is complicated. When you get your results, the interpretation is complicated. And in my opinion, this is because there is a limit in the knowledge dissemination that is done. So recently, the International Society of Electromyography and Kinesiology has been doing a lot of work in increasing the knowledge dissemination with tutorial articles, consensus articles, so has been trying to address one limitation. But to reduce the barriers to the use of high-density electromyography, we need a joint effort of different disciplines. So for example, we need engineers to design cheaper equipment. We need people that develop the algorithms for signal processing, but we also need those with expertise in physiology, because this is extremely important for the interpretation of the results we get. In this context, the Open HD-EMG framework mainly aims at lowering the barriers related to the signal processing complexity. However, we are also working on the interpretation complexity and knowledge dissemination. because in order to fully understand the results you get, you need to know how these have been obtained. And when you are working in an open source project like openhdemg, you also do a task of knowledge dissemination, because both the users and the developers need to share their knowledge to collaborate together. So let's go to what is openhdemg. So openhdemg is an open source framework written in Python 3 with many functionalities that are specifically designed to simplify the analysis of HD-EMG recordings. So in openhdemg, you can import your decomposed file, your decomposition outcome, and there you can visualize its content. You can process and pre-process it to prepare it for the analysis. You can do the analysis, and given that you are in Python, if you want to do something else apart from what is already built in openhdemg, you can expand your analysis with all the fantastic libraries that are already present in Python that we will also see faster later on. But if we look at the definition of openhdemg, we might have additional questions. So for example, what does open source mean? What is a framework? And why we decided to use Python? So open source simply means that whatever we have done so far is completely accessible by anybody. So all the code that we are using, but also the website structure, all the documentation, everything you have seen in the openhdemg project is freely available on the GitHub repository. So you can access it at this link, you can scan the QR code as you wish. If you navigate through the repository, you can search, for example, for the source code. Here, for example, we are in the module related to the figures plots, and you can see how the functions are structured. You have a very good description of all of them, how to use them, but most important, how they work. So you can check them, you can learn from them, you can verify them, most important thing. So the second question is, what is a framework? So far we have seen the library, because when you look at the code, you have a series of functions that you write, and users can call when they write their own code. So this is a library, and is making your analysis easier. But of course, to do this, you need to code and call the functions that have been built in the openhdemg framework. But in addition to the library itself, we also have a graphical user interface, which is a sort of software. But to be more technical, it's an interface between the user and the functions that we built in the library. So from here, you can click a button. This button will call the same function that you will be using in the library. In addition to obviously, this is much easier because you don't need to code anything, but it has limitations because what you can do is limited to the buttons that are present, so you cannot customize your analysis as you would do in the library itself. Apart from that, we have a website. In the openhdemg website, you can find instructions on how to install it, on how to use the library, how to use the graphical interface, but you can also find tutorials on how to install Python and get ready to use the tool. And in the future, we also plan to implement functionalities on how to do the interpretation of the results, for example, how you can understand the output of the functions if you're not really familiar with EMG. So in the website, we also have an important dissemination phase. And then we have the last tool, which is the discussion forum. It is located on GitHub, so you can find it on the GitHub repository. And this is extremely important because can be used by anybody, by the developers, but also by the users to show their feedback, provide their feedback, but also to ask questions. So if you're coding, your code doesn't work, you can come to the forum and ask questions, and somebody from the community will try to address your problem. And then we might wonder why we are using Python. So anybody using electromyography is very likely doing that in MATLAB. There are good reasons. MATLAB is quite simple to use. It's very well performing when it comes to mathematical processing, but it has a very big obstacles that makes it impossible to develop an open source and free project like openhdemg on it. And this one is that for MATLAB you need to pay, and quite a lot, while Python is free and is completely open source. So you cannot just check the functions that we built in openhdmg, but you can check any function that has been built in Python. So in addition, Python is easy to learn, maybe slightly more difficult than MATLAB, but still very easy compared to any other programming language. It has a very strong community, so if you have doubts when you develop your code, you can just check on internet, you can ask ChatGPT and you will find your solution quite easily. But one very important point is that Python is rich of fantastic libraries. And for this reason, Python is the most used coding language when it comes to data science. You have very good libraries for numerical processing. You have very good libraries for numerical processing into tables. And this is a great feature because it makes it much easier for new users to interact with large data sets. Like, for example, we have in identity electromyography. And it also has very good libraries for signal processing. But looking at the future of the openhdmg project, there is all the compartment related to machine learning, which at some point will be the predominant tool that we will use in this kind of analysis. So there is ample room to implement any machine learning technique or approach in Python. Okay, so why we need openhdmg? And I think this is the most important slide of the presentation, because the field of electromyography analysis has been characterized by the lack of available software for signal post-processing and analysis. These situations open to two different scenarios. The first one is that people who cannot code will never be autonomous in the analysis. So this is a problem, but it's a quite simple problem. So you cannot code and you will never do the analysis on your own. On the other side, we have a different problem, which is that those who can code will develop their own scripts. This might seem a good situation, so if you're in this condition, it's fine. But in my opinion, this is the most dangerous situation because it leads to a number of issues. So, for example, if different users use different scripts, the results can differ. So, in order to obtain the same results, in most of the cases, you need to double check how the other person implemented the scripts. Otherwise, there might be smaller or larger differences in the results you get. Additionally, any code that you develop will contain errors. So it doesn't matter how good you are at coding. So there are errors anywhere in Microsoft. There are bugs in Apple. There are bugs in Facebook. There are bugs. So even if you have the best programmers in the world, you will have errors in your code. And if you don't notice the error, so if anybody else apart from you is checking the code, this error will repeat in the following analysis, and you might never notice it. And finally, there is the most important point, which is quite long, but to make it simple, it is impossible to develop a script as the author is using it just from the description that you can find in a paper. So you can find mathematical formulas, you can find pseudocodes, but I mean, it's impossible to reproduce the same exact code that the author is using just based on what you read in the articles. And that's why we need a place where different people with different contributors are sharing their expertise, are sharing their code, and can implement things together. So what can you do in practical terms with openhdmg? So as we already said, you acquire your signal, you decompose it as you wish, it doesn't matter how. Then you import it in openhdmg when you can do the visualization, processing, and analysis. And there you get your results. And with these results, once again, you can do whatever you want. You can open them in R if you want to do the statistics there. You can do that in SPSS, in Excel, or whatever you want. So I think at this stage it's necessary to take a small break and answer one question that I'm sure will come out at the end of the presentation anyway. So why the openhdmg framework is not doing the decomposition? I've been asked this question many, many times. And I think there is a very good reason why. The first one is that there is not one unique decomposition technique. in the last 20 years came out so many different decomposition techniques. Some of them are specific for recording systems, some of them are more general. But I mean, you cannot implement one of them believing that it is the best one and just think that you're done with that. So the first question would be which technique should we implement? The second point is that there are many different ways today to do the decomposition. There are ways that are free, some are paid, some are proprietary, some are open source. But if you check online, you can find, I mean, here I show 4 of them that you might already know. But if you go on GitHub, you will find many more implementations of the decomposition algorithm, and some of them are also very, very good. So at this point, we can clearly say that there are many tools for EMG decomposition, but there is almost nothing for the analysis of the decomposition outcome. And in my opinion, having the decomposition without being able to do the analysis, I mean, is not really useful. Okay, so we have seen that you can do the decomposition. You can do the decomposition from many different systems. And what happens is that you will have many different file sources. They will have a different structure, they will have a different format. And so it will be impossible to do any analysis on all of them because of these differences. So they can be in MATLAB format, which is so far the most common. They can be in formats that are typically used in Python, or maybe can be stored in CSV documents or many other documents. So the first thing we need to do in order to be able to analyze any file source and any decomposition outcome with openhdemg, we need to create a common file structure. Yes, Thomas?
Yeah, just one question, just to be sure. So before importing the decomposed file, do we need to do the motor unit editing in our own software, or is that something you can do with openhdemg? So because it's a large part of analysis, editing motor units.
Yes, at the moment you cannot do editing in openhdemg, but mainly because the editing very much depends on the decomposition algorithm that you are using. For example, there are decomposition algorithms that do not require manual editing, and doing manual editing on these decomposition outcomes will completely change the results you get, while other decomposition algorithms have been designed to be suitable with manual editing.
Okay, makes sense. So we import the decomposed file after editing. Good.
Yes, exactly.
Thanks.
Okay, so once you get these different sources, we need to converge to a common source so that any file that has been imported can be processed with the same functions. If you are a bit familiar with Python, we are using a data structure that is called a dictionary. A dictionary is a really simple data structure because it's composed of pairs of keys and values. So this is our dictionary. So we have different keys, and to the key row signal, wonder what value could correspond. So it's very immediate because keys are text, so it's very easy to understand what we are looking at. And the values, in most of the cases, whenever possible, are stored in tables, because tables are the easiest data structure that we can find, because we will have columns, the columns will have a name. So in this case, for the row EMG signal, we will have the channel 0 of our recording grid, the channel 1, 2, 3, and so on. And so we have the reference signal. It's quite simple to understand what will contain this table. The accuracy measure of the decomposition outcome, again, it's simple, and we have many other pieces contained in our data structure. So that doesn't mean that you necessarily need to have all these things. So for example, you might only have the raw EMG signal, but you don't have the reference signal. In this case, you can still import your file. The final data structure will remain the same, but you will simply have an empty table without any value. So this will not create any error in the subsequent processing. So I really like plotting because I think it's the best way to know what your file contains, but also to see what you got from the decomposition and to look at the further processing that you can do on the file. So in openhdmg, we wrote many functions for plotting, and all what you will see from now on in the presentation has been done with openhdmg. So some of the figures are composite in PowerPoint, but everything comes from the openhdmg library. So here we can see the raw EMG signal. Here we see the times of firing of the motor units after the decomposition. Here you can see the decomposed source for those algorithms that produce it, because not all decomposition algorithms have the source. But then you can look also at the instantaneous discharge rate of the different motor units. And you can also look at the action potential. So for example, in this case, we are looking at a monopolar representation of the action potentials of two different motor units over 64 channels. So once you have your file, you might need to do some pre-processing before the analysis. So this is an example of one of my files, and in my laboratory we have a lot of issues with electrical noise. Luckily enough, it's usually a problem of the reference signal, so you might need to filter the reference signal. And of course, you have functions for this pre-processing in openhdmg, but you maybe forgot to remove the offset before the recording. So in this trapezoidal contraction, you can remove the offset of the reference signal before doing the analysis. At the same time, I mean, you have done your decomposition, you have done your editing, but you forgot to remove your motor unit, or maybe you wanted to look at it in a different way before removing it. So we can say, okay, I don't like this motor unit, here is behaving in a strange way, here it is not firing, and you can remove it with a simple function. Of course, I mean, we never do this, we don't just look at the motor unit and remove it. So we might want to have some more objective criteria to do so, and that's why we can start investigating the coefficient of variation of the motor unit, both looking at it visually, but also directly estimating the coefficient of variation during the steady state or during other conditions where we are interested in. And we can also put this information in context, because it's different looking at this parameter in a trapezoidal contraction, in an explosive, or in a triangular contraction. But in addition to this, you might want to look at signal-based metrics of accuracy. So in openhdmg, you can also estimate the silhouette score, the pulse-to-noise ratio, and so you will have a different view of the accuracy of your decomposition that sometimes can differ a lot from just looking at the constant firing behavior of the motor unit. So you can use this criteria to remove the wrong motor units before the analysis. So then you go to the analysis part. We will start looking at the central properties of the motor unit. So what you usually do is to investigate the discharge rate. This can be investigated in different conditions. You can look at it during the entire contraction, but you can also look at it at the recruitment only during the steady state. And in this context, you usually want to analyze also recruitment and the recruitment thresholds. However, in order to obtain both the absolute and relative recruitment values, you need to know also the maximum voluntary contraction. You can do this in your recording software, but you can simply do that in openhdmg. So you get your MVC and you directly pass the value to subsequent analysis. But apart from trapezoidal contractions, for example, we might be interested in explosive contractions. Maybe we want to do a correlation between the discharge rate during the recruitment of the motor unit and the rate of force development. So in openhdmg, you can also estimate the rate of force development. So we are trying to build a tool that is quite complete, so that you can do all the analysis in the same place and you don't need to switch between softwares. So then you might want to move to the peripheral properties of the motor unit. In this case, the first thing you need to do is to estimate the action potential of the motor units. To do this, you might want to use the spike triggered averaging technique. You already have the function to do so in openhdemg. But if you want to analyze, for example, a motor unit's conduction velocity, you also need to calculate the differential derivation or double differential derivation of your EMG signal. This can be simply done, as we will see later on. So in this way, you obtain the action potentials with a much clearer propagating component and much more defined action potentials. This is the double differential view of the action potentials. So in order to calculate conduction velocity, however, you need to look very well at your action potentials. So this are 64 grids of electrodes, and you need to double check to avoid the innervation zone. You need to avoid the end of fiber, and you need essentially to select the best channels which are more similar between each others. And you can do that from the code, of course, but it's really inefficient. So in your coding pipeline, you can insert a specific function that will call an efficient, convenient graphical user interface. With that one, you can navigate through the different motor units. You can select which column you prefer and then the channels where you want to calculate the conduction velocity. And at the same time, it will also estimate the amplitude of the action potential. So, I mean, you have done your analysis, so you got many results, and then you might be interested, for example, in a longitudinal study design to see how the same motor unit is changing over time. So this is usually done with motor unit tracking, and at the moment we implemented the possibility to perform the tracking by comparison of the motor unit's action potentials, shape and distribution. So in openhdemg, you can do the cross-correlation analysis between pairs of motor units, and you can so understand if you recorded the same motor units at the two time points, and you maybe want to do the subsequent analysis or only on them, or both on the track and the total pool as you wish. So, okay, we have seen that we can do many things, but you might wonder, how can I do this? How can I use openhdemg to do this? So as we already said, you can code your own algorithm, or you can use the graphical interface. So at this point, anybody who doesn't code or doesn't really like coding might say, okay, I only want to use the graphical interface. And this is understandable because sometimes coding can be really challenging. But openhdemg has been built with the scope of being super simple and accessible to anybody, also to those who are not super skilled with coding. And that's why writing code with the openhdemg functions is super simple. So at least give yourself a chance to try implementing your own scripts, which are much more powerful and flexible, of course, than just limiting yourself to what you can do in the library. So in this video, I will show you how you can write your own script to, for example, visualize the instantaneous discharge rate, and also to visualize the shape of the action potentials. So first of all, in Python, you need to import the library. So you have an import statement. And then we call a function that is used to import the file. So in this case, I store the file in a JSON format. After I import the file, in automatic, I have my final data structure. In this case, I want to sort the motor units in order of recruitment, and I write the function to plot the instantaneous discharge rate. So as you have seen, it has been super simple. After that, I want to look at the shapes of the action potentials. So the first thing I need to do is to organize the channels that I have based on their original position in the matrix, in the grid of electrodes. And of course, there is a specific function to do so. So you specify what grid you're using, its orientation. And then in this case, I want to calculate the double differential with just one line of code. Of course, I calculate the spike triggered averaging to obtain the shape of the action potentials. And in the end, I call the function to plot the motor unit section potentials. In this case, I'm plotting the third motor unit, which is the number 2, because Python is in base 0. Okay. So if we want to have a fast look at the code, you can see that, after importing the library, you just need 3 lines of code to visualize the instantaneous discharge rate. Of course, plotting the motor unit section potentials is slightly more difficult, but just adding 4 function calls, you can achieve that. So it's really, really simple. Also, it's very flexible because in this case, you are calculating the spike triggered average on the first 50 discharges, so from the discharge 0 to 50, and on a 50 milliseconds time window. So just to make an example, in the graphical user interface, you cannot decide how many firings you want. So you can do the same things, but you have less possibility of customization. So this is the code for visualization. And let's say you want to analyze the central properties of discharge rate, recruitment threshold, and so on. You only need to import your file and to call this function that is called basic motor units properties, which within one line of code will provide you with all the information that you need. So in particular, you have the accuracy measure that in this function you can decide if you want the silhouette, the PNR, and so on. You have the recruitment threshold in absolute and relative terms. You have the discharge rate at different points of the contraction, so the recruitment steady state. You also have the coefficient of variation, and you also have the variability of your steady state phase if you are using a trapezoidal contraction. So as you can see, the library is really simple. So you should really consider trying it before just saying, no, I will never code. So you might wonder, okay, this is nice, but how can I know how to use the functions? So to use the function, you open your development environment, you simply hover your mouse over the function name, and you will have a complete description of all the inputs you can provide. You will have a description of what the function is doing. So for example, here you can see the accuracy. And let's say you want the silhouette score, you pass the value sil to the accuracy or the PNR or whatever you want. You might also look for other functions that are similar, you might need, but you don't know. And most important, you have extensive examples that will teach you how to use the library. Of course, you can do this for any functions, not just for just some of them. Some that are more complex will have a more extensive description, while those that are simple will have a shorter description. So, of course, in order to access this documentation, you need to know which function you want to call. If you don't have any idea what function you can call, you can go to the openhdemg website. You navigate to the API reference section. So in this case, we were doing the analysis, so you move to the analysis section. On the right side of the screen, you can find all the functions that have been implemented. And there you find all the description. As we have seen before, obviously, it is much easier to navigate through the description here. In this page, you can only see few functions because in the analysis tool, we only place the analysis of more central properties because the peripheral properties are all together in the motor unit action potential modules. So again, you can see examples, you can see similar functions, and you can explore the library. All right, so, but at this point, you might also want to use the graphical interface because it might be sufficient for what you are interested in. And the graphical user interface is composed of a main window where you can find the different buttons, and you can also find the instructions on how to use it, and some more additional information. And from the main window, depending on what you want to do, you will have some pop-up windows specialized in a specific task that you can call. So this is an example of how you can use the graphical interface to do exactly what we did before. So you load your file, you view your motor units, you sort them in order of recruitment, you remove the motor unit that you don't like, of course without any verification here. So once again, we have a signal offset, a signal noise. So we go on the reference signal editing window, we can filter the signal, we can remove the offset based on the average value that we have at the beginning of the contraction. You can resize the file if you have more contractions and you only want to analyze once each time. In this case, it was not necessary, but just to show you. Then you go on the properties windows, motor units properties window. You calculate the central properties, just very few clicks, and you get all the results as we have seen before in the library. So apart from this main visualization, you might need to do additional plotting. So you have a plot window when you can decide whether to show the time in samples in seconds, or if you want to add your reference signal on your image. The plots are interactive, so you can zoom in and you can adjust them. You can also change your size. If you need the figure for a manuscript, for example, you can save all of them with the same size. Then you can do the differential derivations of the global signal. So this is the double differential. And even if this is the global EMG signal, we can see some sort of propagation of the signal. And we can as well look at the motor unit section potentials. Okay, and then we have an advanced tool windows where we have additional functionalities. So for example, motor units tracking, motor units conduction velocity, and whatever we did here has been thought to simplify the user experience. So everything aims at being as simple as possible. All right. So, okay, that's nice, but how can you get started with OpenHDMG if you know, but also if you don't know Python, the Python ecosystem? So the best thing for you to do is to visit the official website, because in the website you can find all the documentation and tutorials. So this is how the website looks like. You will land in the home page. But then you should navigate to the quick start section, which is providing a very streamlined guide that is working very well for those who already know Python. So you can see how to install the library, and then you can see how to load the file, how to do the analysis. So here there are just some representative examples that I try to show you more or less the same things all the time, just to don't make confusion. So you can see that you can do the same things in many different ways, and that you can find information in many different places in order for you to be as simple and as convenient as possible. So being simple is really the main aim of the entire project, and being accessible to everybody. So if you are not familiar with Python and you are learning from zero, you can go to the tutorial section for new users and read this basic tutorial, which is explaining you step by step how to install Python, how to install your development environment, and how to start using OpenHDMG. This is really done step by step, and it's impossible to be wrong if you follow this tutorial. But of course, if you have any doubt or any issue, you can come to the forum section, and there you can ask any question you want, or you can reach us by email, but of course I strongly encourage you to use the forum. So you can find the forum on GitHub. Once again, there is the QR code. And if you are not familiar with GitHub discussions, I mean, it's super simple, but if you never use them, you should read this section here, which is called Welcome to openhdemg discussion. And you will know perfectly how to use it in the best possible way so that we can help you in the best possible way. So, okay, we have seen what openhdemg is doing now. Of course, it is far from being perfect, and it is far from being sufficient to all the researchers to do the analysis that they already do or that they will plan to do in the future. So what we really aim to do is to move from the actual condition of openhdemg, which is an open source framework for the analysis of HDMG recording, from this to move to an open source, community-based framework for the analysis of HD-EMG recordings. So in this vision that we have, the community will be the central part of the OpenHDMG project. The community comprises both those that are developing and those that are using the framework. So, and there will always be an interaction between the two parts. So, for example, the developers might build new functionalities that the users might not know, so they might start using them for their analysis and will provide us with some feedback. But at the same time, different users might have different necessities that we are not aware of, so they can give us feedback and say, hey, look, I would really need this functionality to really use openhdemg. And so we can collaborate to develop whatever tool we need. And this is the technical part, but on the non-technical part, I mean, we have all the interaction and knowledge sharing that will always happen between developers and users or vice versa, but also between users and between developers and developers. So in this vision, everybody is learning from the others, and we share code, we share expertise, and we share knowledge overall. And once again, I insist with the forum, but in order to really create a community that is working together and is helping each other, we should have a common place to discuss things, and the forum, apart of course from conferences where you meet in person or meetings like the one we organized today are cool, but I mean the forum will remain there forever and anybody could read the conversation and find similar problems and solutions at any time. Okay, so if we really want to build a community, we need to have people contributing to openhdemg. And how can you do this? There are, once again, different ways. I don't know what happens here. There are different ways, and to know which ways you can use, you can go to the website, you go to the contribute section, you will find an exhaustive definition of how you can contribute. You can find different ways of contributing. For example, you can help coding if you know Python, or if you don't know how to code, you can still share your knowledge and help us improving our actual implementations, our actual code. But you can also share your code. So let's say you only code in MATLAB, but you still want to contribute to the openhdemg project. You can share the code, and then you can help us to verify the accuracy of our implementation. And but that's not everything, because we, as a community, we also need to be known to attract new users, new developers. So you are also welcomed to contribute in the promotion and advertising of the project. And in this same page, you can also find an open call for contributors. So if you think you can contribute, but you don't see yourself in the categories that we proposed before, don't worry, you can still help us in the way that you prefer. And then there are specific guidelines for those that are interested in developing code to become developers. So this is pretty much everything. So yes, it's almost 1 hour. So thank you very much for your attention, and I'm ready to take question. But I just want to say thanks to the people that already contributed in a substantial way to the library, and in particular to Paul, which has been the one developing the graphical interface. And I can tell you that there are more people that will join the openhdmg project very, very soon as contributors and developers. So thank you very much.
Thank you very much, Giacomo, for this fantastic presentation. I'm really looking now forward to trying this software and maybe also trying to code myself. Also, I know quite nothing about it, but it's really enjoying to see the work you performed and how it's dedicated to help us in our analysis. So congrats for the presentation and for the quality of the presentation and the work you've done. So the presentation is now open to questions from the audience. So if you guys have any question for Giacomo, please raise your hand and switch on your mic. So,
Hey, Giacomo, thanks for the talk. My question is not so much on the package, but on how should I go about learning Python? Do you have good beginner resources? Because
Okay, yeah, learning Python, I mean, I've seen, I've also gone through that myself, and you can search online and you will see so many courses, free, paid. I mean, first of all, you don't need to pay anything to learn Python. You can do anything for free because the project is open source, so there are plenty of people that are teaching it to you in a free way. So that's the first part. The second part is I encourage you to take a very basic course. It can be 1 hour YouTube course where you just know the basics of Python. So how to call a function, how to install libraries, and most important, you need to learn the data structures in Python. So as you have seen here, there are Python dictionaries, but there are arrays, there are lists, so there are a number of data structures. And trust me, you can learn this in 1 hour of course. Once you have done this, you don't need much more if you want to use openhdmg. So you can go to the tutorial section that very soon will become larger. And with the documentation, you will be able to do most of the things you want to do. Of course, if you want to advance, then you could take courses that you can find. I think YouTube is the best place, but also you can find for help on Stack Overflow. Or for basic functionalities, you can ask ChatGPT. He's a great mentor and tutor. But I think for learning the Python basics, you just need to know how to call functions, what a function is, what a class is, but just overall definitions, and then you need to know the data structures, not much more.
Okay, thank you, Anders, and thank you, Giacomo. Maybe one question from myself. Did you try to, or is it relevant to compare the outcomes you may have using Open HD-EMG software to scripts that can be used using MATLAB or using other software like the Muse or whatever the software you may use?
We did an extensive validation of the functions, and in this mainly Professor Francesco Negro provided the greatest contribution because he has been working with high-density electromyography for a while now, and we validated all the outcomes of the openhdmg library with the algorithms that he is using, but also with Andrea Casolo that is working with conduction velocity a lot, but also with discharge rate and so on. And we validate with their algorithms the accuracy of our outcomes.
Right, perfect. Do we have any questions from the audience?
So I take the chance to say that if you believe that, I mean, we should provide a better introduction to Python itself, maybe this is a great chance to use the forum. You can ask the question there, and we will make sure to provide good resources that anybody interested in this can find later on.
I think it could be very helpful because there may be a lot of guys just like me that does not know how to code, and having it seems very simple as you show, but not that simple for us. And having some basics on how to code using Python could be very helpful. So that for sure it would be better for us to code our own script, so that we can analyze the way we want the data. But still, we need to have some basic knowledge on coding. So having some support could be very helpful.
Definitely. And something, I mean, we can do, always using the forum, is we can also try to arrange, I don't know, coding sessions. So we can help each other in learning how to use Python, how to write the code. We can do that. We share screen, we can collaborate. And then we can put what we do open to everybody so that anybody at any stage can learn from what we saw together.
And also having some code sharing using the forum or the website could be very nice too, because most of the time we will use quite the same way to analyze the data.
Also for those that are using MATLAB, because in my opinion, Python might become the major platform used in the future, especially as we move to machine learning, because Python has the best libraries in the world for machine learning. So I think in a few years, everybody will need to know Python. So that's a great opportunity, maybe.
Good to know. Thanks. Enrico?
Yeah, so it's a very obvious question, but if maybe I missed during the presentation. But so first, I wanted to ask if you plan to publish the comparison between your software and the other software, or if there is a way to access to that data. And secondly, is if someone has to reference the project in their scientific work, should they cite like a paper, or there's some indication in the web page?
Okay, so I mean, we don't really plan to publish a comparison between our script and the script of the others. I mean, first of all, because you don't have a ground truth, so you don't know if the scripts that the other did are correct 100%. So I don't think you can really use this as a 100% success warranty. So obviously, I mean, if you develop your script, you compare it with the script of other people and you get the same result. So there are two chances. You both did the same error, which is more or less impossible, or you both came to the right solution. So in this framework, we think that we both came to the right solution, but it's not really a mathematical validation. So I don't think we will ever publish this. And for what concerns the citation, we are trying to publish not really an article on the library itself, but more like a tutorial, an instruction on how to use it properly. So when we publish it, this might be a way to cite the project. But at the moment, we don't have anything, any specific citation, so it would just be like citing a website or a GitHub repository at the moment.
Okay, thank you very much.
Do we have other questions? I guess now quite everybody wants to test or to try the software, so that it will be more easy to have an idea on how it works. And maybe guys will have some questions after having tried to analyze that data using your openhdemg open HD-EMG software. So if we do not have any more questions, I think we can close the session. That was very interesting once again. Thank you very much, Giacomo. And I'm looking forward seeing how we can move forward with HD-EMG analysis thanks to your work. So thanks again.